Okay, so we're just going to start off with a very simple shelf tool pyro explosion before we do any big explosion. Because as I mentioned before, you don't want to complicate stuff when you're just starting out. So what we just will be doing is just create a sphere. So maybe zoom out a little bit. Go to the pyro effects tab. Let's do an explosion. Just the basic explosion. So we just have something to work with. So I'm gonna have this explosion. Quite a simple explosion, but should be good enough for us to work with and develop our effect further. So let's just maybe cache this out. So we have this pyro import here. Right, so let's remove this thing. So this will be our pyro import. Now let's see, what do we need? Well, we won't be using the rest fields for this. Because we will be rendering in Redshift, and Redshift doesn't cannot use rest fields for like displacement of your pyro simulation later on. And also, well, you might do it if you're using another render engine maybe, but keep in mind we will be rebuilding our volume in our flip and like the more fields you will include, the heavier this will get. So I recommend don't like only using the bare minimum. So if we don't need these rest fields, let's just remove them for now. So we don't need CD, don't need fuel. Only thing we need is heat, temperature, velocity, and density. So as you can see, we don't have the colors in our scene anymore. So what we maybe want to do is do a volume visualizer. So volume visualization. This will allow you to set up your visualization. So let's on there go to the drop-down menu and go to density. So you can see now our density shows up. Maybe you want to do a light. So just a general Houdini light in the lights tab. Control click area light. So then at least we can see some shadows in the viewport. Now we can see we have some shadows in the viewport, just a little bit easier to look at. Of course, we will be deleting this later and start using Redshift lights, but for now, let's do it like this. Now go to emission, and let's put the emission to heat. Let's put up the emission and color. By the way, I think we need for the visualization, I think we need to do this with temperature and then this with heat. And let's use physical black body. You can just have a look what it looks like. You could use both temperature or heat for whatever you're doing. For the rendering, we'll be using heat. Yeah, just use it like this, maybe. Right, so now we have a very simple sort of explosion. And what you can do here is you can increase the density, for example. You can see this is quite a low resolution simulation. That's completely fine for now, because again, we want to keep it fast and simple when we are doing our R&D. So maybe let's cache this out. Let's put a file cache. And again, I'm using these presets. Again, you get those in the downloads. So that's also explained in here. They should be in your downloads. So let's delete our start and end frame. Let's only sim up until frame 60, because what we will be doing is after about 50 frames, we will be converting this into a flip simulation. So we don't need a very long simulation. You could do a longer simulation if you want, if you fancy a fancy simulation and just want to look at it. But remember, we're gonna do a high resolution simulator, and only these 60 frames will already probably be about an hour of simulation time, depending on your system settings, like if you have a fast computer or not. So let's just call this Pyro Sim. Just do it version 1, and it's set to $job. So we need to define our $job. We haven't done that yet. So I'll go to File, Set Project, and let's set our $job at our $hip. So now this will evaluate to wherever our hip file is, which is in the R&D folder. Let's save. Now let's just save to disk and sim this out. Okay, so let's have a look at it. So we have a simulation. It's loading from disk now. And you can see this is still not that big. But you might imagine that if we get a much larger sim, that this might get a little bit big. So maybe what we want to do is, because we want to sort of avoid overheads as much as we can, you can also compress fluid simulations. Oh, a pyro sim is also a fluid sim. So just a pyro simulation, you can compress it. So what you can do is, if you type compress, you can say volume compress. And generally, you would want to do this before you cache, but now we have this cache, and we can just easily see what's going on here, and then we'll later cache it again. But all right, so right now you can see not really a lot is happening. So I can say update compression settings. We can have a whole bunch of settings that we can do here. So let's say, for example, use 16-bit floats. So that should already make quite a bit of difference. So you can see that halves the size. Generally, it's sort of, you don't really notice a lot of difference. Like if I put it in here, enable, disable it, doesn't really make a lot of difference. So if you don't know what this means, 16-bit floats, generally a float value, well, a float value can use either 16 bits or 32 bits. And that just depends on how many numbers can be after a decimal. So an easy way to demonstrate this, and this will only work if you're on Houdini 18 or up. Like if you go in here, like make a grid, go into your geometry spreadsheet, and you can see here are our position information. And this is now just general 16-bit floats. So it has a couple of numbers after the decimal, but we can go in view and then full precision. And you can see now we get a whole bunch of extra information. So sometimes you really need this. Like if you're working in a very big scene scale, for example, and you really need all of this extra information, because the information might not be enough to contain all of this information. Sort of similar, like if you have an image and you have banding in your image. If you don't know what banding is essentially, for example, if you have let's say if I googled banding here, let's say this is a color gradient, and if an 8-bit gradient, like if we go from this color to this color, and I don't have enough information, I cannot make this transition properly. But if I do have more information, and I can make this transition properly, well, sort of similar with like attributes. Sometimes you might need this extra, like these extra floats to sort of properly do your simulation or whatever you're trying to do. But for what we're trying to do here with volumes, do we really need all of that information? I'd say we probably don't, because what we will be doing with this is later we will be converting it into flip simulations. So we're going to go through points. So and then we're going to convert it back to volumes anyway. And we don't. You don't really see a lot of difference if we go the 16 or 32-bit route. So if you just use 16-bit floats, you generally don't see a lot of difference. So turn that on. And maybe we want to set up some different compression for different volumes. For example, we could say that maybe we want to compress our density, heat, temperature the way we are right now. But maybe we want our velocity, because our velocity has 3 components, x, y, and z. So velocity makes it quite a bit heavier. Like for example, if I were to delete my velocity, so if I just go in here, if I go over here and I delete my velocity, so delete. If I put a star here, then it will delete that. You can see just deleting the velocity more than halves what we're doing here. So let's put it in here. So if we delete it in here, you can see only 3.69 megabytes is left from whatever we're doing here. Well, we do want the velocity because we need it for motion blur. But do we really need super accurate motion blur, or do we really need to carry over the velocity super accurately from our pyro simulation into our flip simulation? I don't think so. So what we could do is say that we want this volume compress to be on our just our base, so on density, heat, temperature. Copy another one, and let's do this one on our velocity, and put a star so it works on all of our velocities. And let's work on our compression. So we can turn up these sliders. You can see, let's turn this off. So over here it will be 13 megabytes, and it will be 6 megabytes. So that's because of these settings. So if I turn this down again, so it already gets smaller because of these 16-bit floats. Again, if I don't do that, it's bigger. 16-bit floats makes it smaller. And then basically doing this will also just make the whole thing smaller in general. So what we can do is just, maybe if we want to try this out, if we put down a scatter some points in our density. So go in here, do it on our density. Let's turn off relax iterations. All right, so we get some point. Now do volume trail. What volume trail will do is it will trail our point based on a input velocity. So if we put our velocity in the second input, and then say that we want to use our velocity. Okay, so now it's trailing. You see, making trail, so we can sort of visualize this velocity based on what we're doing. And so what we can do is, we can, if we play with these values, do you really see a lot of difference in your visualization? I don't really think so. A little bit. It's going to be less accurate. Like if I really crank it up, it's not going to have all of the information, but no, it's 16-bit. There's some difference, but is it really, right now we're under like 5 megabytes. We went from 15 megabytes all the way to 5 megabytes. Well, I'd say we can probably get away with compressing the velocity quite a bit. And again, right now, this is not really that big, but keep in mind, we will later, we will really be dealing with volumes that are a couple of 100 megabytes a frame. So they will be really big. So then this is really going to make a very big difference. So this is what we want to do. So now that I've sort of explained this whole process of compressing your volumes, let's just cache those in. So because, right now I was just doing this on our cache because then it was just easy to explain, so I wouldn't have to worry about losing this cache. But what we can just do is just append it like this. Now let's save it out. So again, we have this. So we go look in here. Right now, this cache for 60 frames is 412 megabytes. Let's save it out again. Turn on initialize simulation. If you turn that on, it will initialize the simulation underneath and it won't write out the already cached stuff. So we save it out and just see the difference. If you want to do, maybe we can version up. We can sort of see the difference easier. So let's save a second version, save it out, see the difference. (152 megabytes). So quite a big difference, right? So if we go through the two, you can't really see that much of a difference. So anyway, so now we have a much smaller cache, only a couple of megabytes, still have the same simulation. So now that we have this, what we can do is maybe now start converting this thing to a flip simulation.